This is our second video on acceleration and velocity vectors. Here we have some velocity and acceleration vectors given, and we want to decide, are we speeding up and turning or slowing down and turning for each case? What we can see here is that there's an acceleration component that's in the same direction as the velocity. So for this one on the left here, we're going to have speeding up and turning. And we'll demonstrate the speeding up bit by breaking this acceleration vector into one component that is perfectly parallel to the velocity. And then, now watch this. See, if I put a perpendicular component, I could draw it right there. You see how that acceleration vector is then the hypotenuse of my triangle, but I'm not going to draw it there because usually in physics what we want to do is we want to put the tail of the vectors touching where the vector is acting. So it's preferred that I write it over here like that. But you can see that my tangential acceleration vector is causing the speed to increase, and yet centripetal acceleration is going to cause the object to be turning. So it's going to be speeding up and turning. How about the second one? Same sort of thing. There is a component of acceleration that's in the same direction as the velocity. So this one's going to be speeding up and turning. And if we draw two vectors, there we go. So there's my tangential acceleration. And then once again, I'll show you kind of where we could draw the perpendicular component. Watch this, right there. But as I said before, in physics, we like to draw the vectors such that their tail is connected to the point where that vector is applied. So it's preferred that we draw it like that. Speeding up due to the red vector and turning due to the green vector. Now, what about the third case? Here you can see the acceleration is kind of going in opposition to the velocity. So here we're going to have slowing down and turning. Here, the tangential acceleration vector is going to look something like that. And the centripetal acceleration vector is going to point like that, slowing down and turning. And finally, here again, slowing down and turning. Let's break this acceleration into a component that is parallel to the velocity and a component that is at right angles to the velocity. There you go. Let's do something similar, but here we're going to draw and label a vector that satisfies each descriptor and draw and label tangential and acceleration vectors. Let's start with the tangential. Slowing down. Okay, which way does my tangential vector have to point? That way. How about the next one? Slowing down. My tangential acceleration vector must point like that. What about here? Speeding up. Tangential acceleration must point in the same direction as my velocity. Speeding up. My tangential acceleration has to point in the same direction as my velocity. So that's the slowing down, speeding up part. Now, the changing direction, it has to be at right angles to the velocity. It doesn't matter if we go up and to the right or down and to the left. I'll go up and to the right here. The centripetal acceleration vector is going to look like that. How about in the middle one? How about I draw a really big centripetal acceleration vector? There we go. How about here, turning? It doesn't matter which way. You can point the centripetal acceleration vector up. You can point it down. I'll point it down. And how about here? Let's pretend this time it's just a real tiny acceleration centripetal. Check that out. The red vectors cause the speeding up or slowing down, slowing down, slowing down, speeding up, speeding up. The green vectors represent turning. Green vectors are centripetal acceleration vectors, and they are always at right angles to the velocity. So the overall acceleration is going to be, if you tip to tail, the red and the green vectors. So I'll draw this as best I can. Maybe you can draw them a little better than I can. Stop the video where you need to. There we go. Whoops, that's not a tangential acceleration. What am I doing here? not tangential. Oh, T is for total. Yeah, T is for total there. That's okay. So that's how you do that. Now, in some cases, like in one-dimensional motion, we only had a tangential acceleration, right? There was only acceleration causing something to speed up or slow down. In uniform circular motion, where something's going in a circle at a constant speed, there's only centripetal acceleration. But sometimes there could be some of both. There's some centripetal acceleration and some tangential, in which case the speed will be changing as well as the direction.